Hey guys, I'm going to talk to you guys a little bit about the St. Louis motor here, and I apologize I can't be there today, but I'd still like to make a little progress on this, so I'm just going to go through the parts. So this is the St. Louis motor. I showed you this sort of yesterday, but we didn't get to talk much about it. The big thing about motors is motors take electricity and create movement, where generators take movement and create electricity. So they're the exact opposite of each other, even though the parts are almost the same. And so what we're going to do is we're going to look at the parts of this guy here and try to get a good understanding of what it is. And we'll get the instructions, and then I'll go through it again quickly with you guys when we come back so I can show this to you. But let's just quickly go through the parts and how this operates and works. So it's really not that tricky for us to look at. Up on top here is, if we look at right on the top, these two things here are what we call the posts. That's going to allow the electricity in and out through this device here. Okay, and so we'll hook that up right away. Going down through the posts, so here's one post, here's the other. They're going to go to these two things called the brushes. Okay, and the brushes can move, but we don't want them to. We want these brushes to brush right up against this center part here, which we call the split ring commutator here. Okay. Now, if you notice, if I just separate these out, here's that split ring up here. It's got metal, and when the metal is touching the electricity, so when it's touching the brush or the brush is brushing up against it, electricity can flow. When it rotates around into the gap, and there's the gap here, you can see that big black gap, the metal can't touch. So when it's touching the metal, electricity flows. When it's not, it's off. So on and off and on and off as it moves about. And so that's what's taking place here, is that the brushes are brushing up against this split ring in the middle, boop, boop, right there. Okay, I can point to it with the Lego if you'd like. There it is. And what's going to happen is that electricity is going to flow down into these coils of wire. Now, if you notice, the coils of wire are around this piece of metal. And so what's going to happen is the electricity is going to travel down through the post into the brush, touch the split ring commutator, which is going to allow the electricity to travel down into this coil of wire around this metal. And then what it's going to do is it's going to flow all the way up to the other side. Now, we talked about this yesterday. When we have wraps of wire around a piece of metal and we allow electricity to flow through it, we get an electromagnet. And so that's what that's going to become. So if I hook this up, so I'm just going to add my power into this, right there, okay, and turn my power on. Okay, we'll see that we actually create this electromagnet here. So let me turn the power on. Okay, when it's in the on position, and you can hear it. Well, maybe you can't, but nothing, and then it's on. Okay, it's on, and it's nothing. When it's touching the split ring, okay, and sometimes you can see it spark just a little bit there. It's actually creating that electromagnet. If we wanted to test to make actually sure that it's magnetized, we can just use some metal, okay, and we'll notice that these do stick pretty easily to this guy, okay, and so they are magnetized and they'll just drag along with it, okay, and so there's our electromagnet. So this is really just creating an electromagnet, but the problem is this really isn't moving, and the goal of a motor is to move. And so the electricity is coming down through the posts into the brushes, touching the split ring, turning on this electromagnet, and then coming back out again, but there's no movement, okay? And so what we want is we want that electromagnet to be able to move. So how we get it to move is we bring in these guys, which are our permanent magnets. Now, our permanent magnets stay permanent, okay? Now, what happens is, if we can actually watch this for a second, we know that, okay, magnets that are opposites repel, or of the same repel. And you'll notice how it just switched around there. Now they attract. So that's opposite ends that we end up having. So once more, we get that repulsion, and then, well, what the... All right, let's get rid of that. Okay, so we get that repulsion, and then that attraction that takes place here. Okay, and so all of a sudden, it attracts. So those are opposites. But what we want it to do is we want those I hope we're going to edit that out. We get that opposite there attract. So what we want to do is we want to get this electromagnet to be repelled by the permanent magnets. And watch what happens when that takes place. Okay? So what's happening now is the electromagnet is being repelled by the permanent magnets. And as we get them closer, the magnetic force gets stronger and we can get this thing moving along. Now you can see by the brushes that we're actually getting a shock that's taking place there. Okay, so we can see that we're getting those sparks. But this is what we start to get. We get that motion that takes place. So in the brushes you see the sparks, it's turning on the electromagnet. The electromagnet is being repelled by those. And as long as we just sort of sit here, this thing will rotate, move, and move, and move, and move. If we move the permanent magnets away, that attraction stops. Or that repulsion, I guess, of the magnets. As soon as we bring the magnets back in, it starts up again. Okay? Now, we see this in many, many things. We see this in blenders, we see this in fans, CD players, hard drives. We'll all use this idea of the St. Louis motor. Now, we got to ask ourselves, though, is why does this actually work? Okay? Because normally you would think that if the magnets wanted to repel each other, they would start to repel. But when they lined up, they would stick together. And so you would hope that you would get some motion, you would get that repulsion, but then we don't want it to stick together. And so remember we talked about with electromagnets is that we can turn them on and we can turn them off. And whenever this hits the split ring, it turns off. And then when the brushes touch, it turns on again. And then the split turns it off. But when it touches the ring, it's going to turn it back on. And so all of a sudden the electromagnet, we can turn on and off and on and off. So it's off and then on and off and then on. And what the split ring does is it reverses the polarity of that electromagnet. And so north and north will want to repel when they're the same polarity. Okay? But then it wants to repel and it'll turn to the other side. But halfway through it's going to turn it off. And then when it turns it back on, these two sides will be north and north again. Okay? And then it'll turn off and north, and then it'll repel. It'll turn it off and then turn it on, and north will repel. And you can see I can just do this with one. Okay? This is north, and every time this spins this way, it's north again. And they just repel and repel and repel and repel. And we get motion being created by the electromagnet being repelled by the permanent magnet that we end up having. Okay? Now this whole arm here that it's all spinning on is then called the armature. Okay? So from the top to the very bottom, this bar that it spins on is the armature. Now if this was a drill, this is what you would actually attach the drill bit to. This would be inside, we don't see it, but then we'd attach the drill bit down near the bottom. And when we turn the drill on, what we happen is we see this drill, whoops, you can see they're not lined up. The drill will start to spin because of that repulsion that we end up getting. Okay? Now, if we look at something along the lines of this guy here, now I just pulled this out of my car. Part wasn't working, but this is a motor that we get from a car. This is exactly what this is. Okay? Except this is a bigger version of it. This is the smaller version that we end up having. Okay? And sort of same thing, and this is what we played with in class. If all of a sudden we hook this up, and this motor actually may be burnt out, but we'll see. Oh, there it goes. Okay? It just starts flailing away and rotating away as we add that electricity in. But that's all that's inside this, is the exact same thing that's in this device here. Okay? So we have our posts which carry the electricity down into the brushes. The brushes brush against that split ring. That split ring turns on an electromagnet, and the electromagnet gets repelled by these permanent magnets. Okay? Now you can see there's no repulsion right now because there's no electricity in the St. Louis motor. Once we turned it on, what would happen is it would actually make this north and north, which then they would repel, and that's where the movement comes from. Okay, and the stronger the electromagnet, the stronger it repels the permanent magnet, and the stronger the rotation that we get. Okay, and we see motors like this all over the place. But this is the part of the St. Louis motor. I hope this sort of helps as we go along. Okay, thanks guys. So now what I want you to do is I want you to get the notes down into your textbook or into your note sheet that we had. Make sure you've labeled the parts and then just fill that in. It'll only take about 5 or 6 minutes to get that in. So it's a little bit of writing, I understand that, but then it'll be done. Thanks guys.